Okay, so in this video, I'm going to talk about some of the assumptions of multiple linear regression model in order to get unbiased estimators from these type of models. Here is the population, and all we have is we have some sample out of this population, and we want to analyze these beta coefficients from this sample. So these beta coefficients are coming from this sample, and this population, it has its own beta parameters. So let's call these population parameters. But we don't know those. All we have is we have these sample statistics. These beta i's, and this is the original beta I. And we want to measure the effect of these x variables on these y variable. And essentially our goal is to bring our estimated values of these beta parameters or these coefficient values to these population parameters. So that is the whole point. In order to do that, we use ordinary least square estimates. We use this estimator to estimate these beta coefficients. And we saw even in the case of a simple linear regression model that in order for these beta parameters to be close to the actual betas, that is the expected value that we measure, and that value is equal to the population parameter, in order to have that, there are some assumptions that must be met. Here I'm going to talk about 4 assumptions that must be met. I already talked about these assumptions in the simple linear regression modeling framework. The first one is the model is linear in parameter. So the function is linear. The second we discussed was that the sample is picked up at random from this population. Right? These samples that we picked, the assumption is there is no systematic way of picking up these samples from this population. They are picked up randomly. And the third assumption that I talked about was that the expected value of this error term conditioned on these x values is 0. And I talked about this assumption in one of my previous videos as well. If this is equal to 0, this is called that our x variables are exogenous. And if this condition is not met, then these variables are called endogenous. The fourth assumption that I'm going to introduce here is there is no perfect collinearity between these x variables. So what is perfect collinearity? So if an x variable, it's a perfect combination of another variable x2, it is called collinear with that variable. Let me give you an example of two variables x1 and x2. Say we are interested in a model of measuring the impact of square footage. Let's call this a function, square footage, number of rooms, etc. on house price. Say this x1 is the square footage, but we also include square inches in this model. So say this x2 is square inches. As we can see, these x1 and x2 variables, they are representing exactly the same thing. These are not two variables. Rather than x2, it can be represented in terms of x1. So say, apart from this example, perfect collinearity means that if the value of x1 is 2, for example, x2 could be, say, 4. If the value is 3 here, the value of x2 is 6. And if it is 8, the value of x2 is 16. So seems like x2 can be represented using this relationship. Then we say that x1 and x2 are collinear. So the OLS will be unbiased if there is no perfect collinearity. Some linearity or some collinearity, it is allowed, but perfect collinearity is not allowed. For example, there may be like a slight relationship between x1 and x2, that is allowed, but this is not allowed. It should not be a perfect combination of another variable. So that is what perfect collinearity is. And in some of my other videos, I'll probably explain you what happens with OLS if there is perfect collinearity among your variables. But here I'm interested in telling you is that if any of these assumptions are not met, then OLS estimates will not be unbiased. So be careful about this. All right, I'll see you in the next video. Bye-bye.